Welcome back, our fellow learners of the Polkadot Bootcamp. Today we're gonna solve the exercise, one of the very common exercise of the Polkadot ecosystem, called Introduction to the Rust Stack Machine. This exercise guides you to how to implement a stack machine from scratch using Rust programming language. This will be quite close to the substrate, and this stack machine design is also what is the design goal of substrate. So after this exercise, you're gonna get the overall idea of how substrate is designed and how the palette registrations is added to the design of substrate. Before we solve the Rust machine exercise, I want to shout out a huge shout out to one of the very talented engineer of Parity, and also now the Polkadot fellow. He is Saul Tabrizi, and he also my former instructor from the Polkadot Blockchain Academy. So big shout out to Sean for making a lot of great stuff to contribute to the Polkadot ecosystem. Before you go to the live coding part, I just want to give you a disclaimer that this video is actually an additional sections of the whole Open Polkadot Bootcamp, and you actually don't need to go to all my live coding part, but just go straight to the Rust Stack machine, follow all the guidelines, and you're gonna get it. Because the reason why is my video is already recorded back to 7 months ago, when I would just get started working from OpenGuild. And my skill back then is not very good, especially related to the Rust skill and also my English. So and I didn't prepare very well for the live coding part. If you are not comfortable with that, so just ignore this section video and then go straight to the next one. Yeah, thank you.
So what is a stack machine? In the stack machine is gonna have a few things like stack machine transaction function, or we can say SDF, deterministic stack machine, and non-deterministic stack machine. So I don't talk about deterministic stack machine or non-deterministic stack machine today, because those are a very deep concept, and you guys can research it. But basically, we just talk generally about the stack machine. So what is the SDF? So SDF basically just a function in programming that help to transit the state of the state machine from state A to state B. As you can see here, so state 1 to state 2 is required as transition. So this transition here is called the SDF, or state transition function. There is a function to invoke. When you invoke, it's gonna switch the state from state 1 to state 2. For example, the light switch. So the light switch, for example, you have the first state is on and the second state is off. And to switch the state from on to off, you're gonna have a SDF called toggle. Now we're gonna implement the state machine in Rust. This is very interesting. I will send you the reference here. Now we go to the coding part. I will code with you in real time. So if you want to practice this, you should code with me too. Okay, now we are gonna need to create a new project for stack machine. Now we have a Rust machine. All right, so now we go step by step to this material. So follow the live stream, or you're gonna be miss it. So first is introduction to the Rust machine, and what is this material? This is a guided tutorial intended to teach readers the basic Rust, blockchain, and eventually the inner working of the Polkadot SDK. You can read here. So the guy make it to teach us about the substrate state machine. So yeah, I will skip that. Initialize your Rust project. I hope that you already ready for this. So if you coding alongside with me, so if you have any problem about setting up, so just tell me so I can help you. So I will skip the first section too. Now Rust tooling, that's fine. I don't care much about it, but we can copy it if we want. Just create Rust fnt Tom. This is basically a formatter. If you guys have experience with Node.js or JavaScript stack, you may be familiar with Prettier or ESLint. It's basically the same thing. Now we run a Carol format. has it. Yeah. All right. So we go to the first one, the balance palette. So is it the balances palette? Maybe don't think about the palette, but basically, like in Substrate, the palette is basically a set of modules, a set of libraries that provide the logical functionality to the Substrate runtime. And this is one of the ballasts that is provide, the transfer cryptocurrency, the transfer value between one address from to another address. And the original one, it can be found here. Balances. So in this palette balances, you can see there's a few methods like transfer, like do transfer, and many other things. But it's basically, yeah, there's a material. It's basically like setting free balances, and then retrieving total reserve and reserve balances of the account, like repatriating a reserve balance to something like. It's basically, to provide the value transfer functionality. So if you go to Polkadot, the mainnet of the Polkadot, enjoy it, you see it here. So if I go to RPC, let me see, extrinsic, and then there's things called balance. So in this balance, you can force transfer, or you can, transfer from one destination to the value. So what does that mean? That mean like things like subwallet. So when you use subwallet and then you do send token from one token to like you select a token and you send it to an address, and then you enter the amount. That means like it's using this palette balances. So that's what it does, and this is basically SDF. That is provide, is a function that is provide a state transition to our state machine. So that we're gonna do. Now we go back. So we will implement it. So first, the tutorial say create a new public struct named palette. All right. Yeah, basically we just, create a simple job. Then we go back here. Then we, all right. Okay, so we create a simple struct palette and we finish. Now we go to the next step. So a state to our palette. So as a simple state to our balances. I haven't read through this material yet. So that's mean like I also follow this. I also work on this material at the same time with you. All right. So what does it mean is like it wants to create a B-tree map to store, like to link like from one address with the value of it that is content. So now we're gonna have to like use std collection the B-tree map. So we import the B-tree map to our project to store the value. So it's basically what this means. It's gonna, for example, if I have Alice, so Alice is gonna store like 200 dot or something, and then Bob also store like 100 dot. That's what it does. And then in this palette we have maybe the balances, and then like B-tree map. So what's the key? So the key, maybe I will call it maybe type address. Yes. Let's say the U in 33. The address, the value, maybe call the value as the balance. So we have the type alias balance. It's also U32 balance. All right. Go back. Yeah. So it store the address as a string. That's fine. to update a string and you 128. Now we want to implement the ballot a bit. Stop. Confidence. Right, so it's have a setup thing here. Just copy. So what it want us to do, we will have to implement this set balance and balance. It's quite simple. So it's just hash mark. It's just b3 mark for a method. So we do self balances, and then we insert. The key is the who. Is it? The key is who and the amount. So we must dereference the who because who is reference. Oh, so we have to plot. And then return the balance of who, returning 0 if none. So it's going to be self.get balances get, and then the key is who, clone again, unwrap or 0, right? So, oh, yeah, it's quite weird because I don't sometimes I'm very stupid. Like I'm very bad at the ownership and borrowing. I still understand it, but I don't remember when to use it and when to remove it. I have to read the instruction. So sorry about that for my non-experience. Okay. We can write a simple test for that. Test. This is the right macro. Test. Balance or function balances work. And then we initialize new palette balances db, we call it palette. So we initial a new one and we set, and then so do we have to set this to mutable, and then who maybe Alice, and the amount is 200. Okay, so after we set, we're gonna try to get. Wait. And then we say the owner. Yeah, owner is else. Well, today there's too many people watching the live stream. Like there's 11 people. Like in the last live stream, there's only like 2 people, and it's already include my account. Right. So after the setting, we get the balance. It's shadowing. So it's called expected. No, it's can make a call it n, and then we have the expected. So we assert equal balance with n, and we run the test. Cool, very simple one. All right. Now we finish this this things. We go and any other things we want us to do. Cool. Solution. Cool. Very simple. Now we go to the next one. The next one is basic balance test. We already did this, so we skip it. Enable balance transfer. So what there is want us to do, so we will have to write this transfer method. So transfer amount from one account to another. This function verify that form has at least amount balance to transfer and that no mathematical overflow occur. So get balance of account caller. So just caller. And then we do self balance to caller. And then we get to let's say caller balance and to balance self balance to use self math to calculate a new caller balance. We want to send the amount. So transfer from caller to 2, caller to 2 with the amount. That means we have to subtract the caller balance. So that means if the caller balance saturating should. So what is the method saturating should does? It's basically equal to caller balance minus with the amount, but it is in a safe way. What this means is like, for example, if you do 0 minus 1, which part that you don't understand, I will explain it for you. So if you do like 0 minus 1, this will throw an error. Throw an error if you do this approach. But if you do 0 saturating should minus 1, this will just basically, as I remember, oh, this one is told. Wait, there is told something. Just told something. Actually, I don't remember. Is oh, yeah, it doesn't told anything, but it's just basically 0. That's what the method does. Sorry. So we do if the caller balance saturation sub, and then if the caller balance sub with this thing is equal to 0. So if it's equal, or maybe this is not the right way to do that. So if it's smaller than the amount, then we panic. No, we return error. Or let me install a library. So I need to install a library called anyhow to handle that error easier. Anyhow station. I'll go add anyhow. So what does anyhow does? Here. So anyhow, it's just basically a grad, Rust grad that is allow you to handle the error in a better way, like in an easy way. Error in Rust is really hard to handle. So we can use this library anyhow, and we import it anyhow. Just add it. All right. Where's my library? Where's my library? What? That's really weird. Anyhow, yeah, I know it's error, but I want to return a message. Message. From string. Mm, the thing is, this is what I expect it to be. Like, I remember like the anyhow it has what you see, like I cannot import anything. Oh, I just remember I forgot to add this. Oh, I add this as a workplace already. No, the thing is I cannot import anyway. But this is so embarrassing because I don't remember like how to handle this error. I usually use this error and anyhow, but I forgot like how to handle it. Any case like string error. Come on. Oh, just do panic. Maybe just do panic. Below balance. We will we will figure that error later because that's very embarrassing because I don't remember how to handle that. So if the caller balance is below the amount, then we panic below balance. So if caller below, and then get the balance up, use SafeMath to calculate the new caller balance. New caller balance equals to the caller balance saturating soup amount. Then we have new to balance to saturating at do the same thing. So let's move it here. So what does saturating at means? For example, if you have the U33 max value and then you try to plus 1 to it, this will throw an error because it have the value overflow. But if you do U33 and then max, saturating add, you add 1 to the max value, which is already the max value, and you try to add 1 to it. It just basically just return the U33 max. That's how it works. Insert new balance callers, insert new balance to 2. So we do self set balance color and mouse new color balance self set balance to new to balance. Let's copy this test. We run it. First tab finish, rare test. Let's check the following. The Alice cannot transfer fund. She does not have. Oh, maybe we should handle the edge case that if you transfer something to like if Alice to transfer to Alice account as well, it doesn't work. So if caller equal to 2, then we panic again. We panic. Transfer to Sam address. Or just for a little bit, just reference it doesn't have. So now we need to initialize Alice. Balance. So we add Alice and can transfer the funds he does not have. So if we actually don't need to set, but we just do balances transfer from caller is string from do like Alice, and then we do pop. So if we go with the amount as expected, like panic, should panic. Expect the string, first string. Yeah. What? It should panic thing is much. Oh. Yeah. Let me just to project the solution to see how they handle the error. It's very bug me. What? This guy doesn't handle any error things. Wow, I didn't know that we can do this. I thought like you have to use anyhow to handle that, because anyhow it has some method like anyhow error and a message. And I usually just use this instead of use that error traditional way. So this is gonna be, so we do expected, and then we insert expected to be 2. Then we run, then we finish. So Alice can just successfully transfer fund to Bob. So that means we have to set the balances, to set the balance of we set the balance of Alice with 100. Here. Then after we set the balance of Alice, we're gonna maybe we will set the balance of Bob as well. Set it to 200. Then we balances. Then we transfer from Alice in pop with the amount is 20. Then we unwrap because we know that this is gonna be success. And after we do that method, we're gonna check. So we check access equal balances. Yeah. Wait, what's our method? No, it's not balances. It's balance. And equal. So after when we do transfer from Alice to Bob, it's gonna be 80. Oh, and we have to do because like this Alice is O by the transfer method, Bob is also O, so we must do balance. So do you notice anything like? Oh, never mind, nothing. So we assert equal balances, balance, and then Bob, and then we transfer 20 from Alice to Bob. So now Bob, we're gonna have 220. Then we run. Now it's run with success. We go to the next stage, system and runtime. Interesting. In this section, you will create a system palette, a low-level palette for managing basic blockchain state. Then you will integrate both the balances palette and system palette into your state transition function called the runtime. And anyone here already, work to the substrate, go to like a few substrate article or on the low leveler? So let's see. Palette. So if you go to the frame palette template, you will notice that we have a things called frame system config, and you may notice that like every palette is like use this frame system config, and that is the config that is like the system config that we're gonna implement, which is applied to all the palette in the substrate, in our substrate. Now we go back. Okay. Introduce the system palette. We have basically completed the creation of basic balances palette. Is the palette that most users will interact with. However, your blockchain usually needs to keep track of many other pieces of data to function properly. For this, we will create a new palette called the system palette. So what's the system palette? So the system palette is a meta palette, same like meta protocol. So if you don't remember, like meta protocol basically is one thing, they generate another protocol, and system palette is the same. System palette is one palette that is provide the ability to create another palette. So the system palette is a meta palette which store all the metadata needed for your blockchain to function. For example, like the current block number or the nonce of user on the blockchain. It's just like general information of the whole blockchain. That order, like that, all the palette can learn from it and then reuse that information. Right here, like it's trying to like separate and just do the same thing. We will bring all the balance palette code into a new file, and then we import it here. So it's gonna make like it's more it's more organized, and it's below coupling. And then we copy. So type address type palette. I don't think like can still use these, right? We just call this like type. And copy all the whole Palestine. Transfer. This. Make it cleaner. Oh, actually, you don't need this mode because we already tried to separate it. So why? Yeah, we don't need that. Do we need that? No, we don't. Yeah, we don't need that. Now go back to type, import type, import. Yeah. Then we copy the whole test and bring it to the new file. Brand one system. We also have a struct palette. System functional. Just copy the whole template. We don't need that. Okay. All right. So what is our system palette does? So this is system palette code. It's handle low level state needed for blockchain. The current block number. This will taught me like it should be core. Like we will give the type alias to all the information because I cannot get it. So it's just null equal to u33. And then we also have the block number. If you notice that, like I just follow like in the substrate. In the substrate, we also have that. If you already did the substrate before, we will notice that. So the block number is also u33. Then go to man system. Just then this is gonna be just nonce equal to man. It should be the block number. Return the current block number. This symbol. Cell block number. Increment the block number. So this function can be used to increment the block number, increase this block number by 1. And we do that. Wait, what heck? Increment the current block number by 1. Increment the non-open account. This helps us to keep track of how many transactions each account has made. Yeah, like in the blockchain, like we have nonce, like adjust nonce. That is to indicate like the height of the height of transaction already met by that one adjust. And then we do self dot what kind of things we have? Nonce. And then like we do a self nonce. We saturating. Oh no, we have to get. Oh, they just, like that once. Between and then we adjust noise and then adjust. So get noise, so we match if there's a nonce. Okay. We I think like we have some kind of method called map. Anyway, let's do increase noise, get mute noise. Right, get mute noise and check mute. We get a mutable plus, and then we some if there's a nonce, we return the mute. Get mutable. Error. Just panic. Oh, this should be nonce. There's no error here. No, it's non-file for address. And create access feature. Increment the current block number. Increment the current block number. Everybody knows about this. So system palette and then new system different kinds of new P3 map, increase block number. It doesn't give any method for create a block number. Just not just it doesn't give any method to set the nonce of the address. So I think like increase nonce. So it must be like this. Yeah, we no longer need this method. So we got, and then we do saturating it 1. And then if there's no, then we just add self nonce insert who value 0. Oh yes. Increase nonce of Alice. So Alice equals string from Alice Alice increase nonce. And raise the current block number. Check the block number is what we expect. So insert equal system dot block number is 1 and insert equal system dot check the nonce of Alice is what we expected. Nonce. So nonce get Alice. One as well. Okay. Increase Alice. So we get Alice. Why is get or insert? Unwrap. Unwrap or mutable. Visualize it. Oh, we found this first line. Increase block number. Saturating it. Block number. Block number. Block number. Block number. What? It's really big. Oh, I just saw one question. Sorry. So I missed the part where you explain the differences between the step machine and virtual machine at the beginning. Yes, definitely. I will just come back. I still wonder, like, why this block number is not increased. That's so weird. It's supposed to be increased, right? It's interesting, but that shouldn't be the case. Ah, I just remember. I thought like it's like the plus base, not like what I expected. It should be. I just remember. I'm so stupid. It should be like this. And the below one must be the same thing. So self get mutable. So we say who nonce okay. It's become complex a bit. It's become complex in an unnecessary way. Let biting equal to 0. Come on. Default value. That's so annoying. Append insert key who value self get. All right. Now it's asked us to create a runtime. Create a runtime. Now we go back to the main for RS. Create a few system using system power. create a new instance of the main runtime by creating a new instance of each palette. So we just create a new instance directly, and then we do system palette, and then we do balances. Yes. What the heck? How do you handle this? Solution should pilot then here what? We did the same things. So it's say that mismatch type palette balance. Palette and system palettes have similar name but are actually distinct type. It's fine model in the current red. Oh, I think. Can we handle this? I think they did mention something. It's wrong. System palette is defined here in the mode. Use trade. Ah, that makes sense. I didn't need, but I don't see it mention anything about no, because like no, there's no trade. Let me just search this for Google, like Sam struct name on different module. That's weird. We don't like that. Didn't mention anything about this. Hmm. Any idea, guys? I have no fucking idea why this happened. It's really weird. Uh, hmm. Oh, damn it. I don't find any reason why. Oh, shit. Man, I was so damn stupid. I just pointed to the wrong stroke, so it doesn't work. Oh god, that's the reason why I feel so weird, because that's the first time I see something like that. We are new runtime by creating the new instance of system balances. Cool. Now we go to the next step. I think we in this chapter, and then we do. Right, we finish this step already using our runtime. Then man, create a mutable variable runtime, which is the new instance of the runtime. Set the balance of Alice, so we point to balances, set balance Alice equals string from to 100. Start emulating a block. Increment the block number in system. So we call system block. Increment the block number in the system. Assert the block number as we expect. Assert runtime system block number equal 1. Increment the nonce Alice. Runtime system nonce, given nonce, string. Execute the transfer from Alice to Bob for the token. Runtime transfer from Alice to Bob. So we're going to do balance palette transfer. Says Bob. So let's import the token. The transfer could return an error. To use map error. Mm. Now that we can import the anyhow, you just see that? I don't understand why. It's weird. What do you want me to do? Curious. Error. And this. That is better. Synchronization categories options for use. Transfer second transaction. Enrollment and nodes of Alice again. I'll just copy this. Execute another balance transfer. This time Alice to Charlie for $20 for 20 token. Charlie. It's running, but we don't have any. Oh, I think like this section is it has some cool, like it has some information that we should understand. So using our runtime, until now we have just been scaffolding part of our blockchain. So tests have ensure that the code we have written so far makes sense. Simulating a block, the input to any blockchain state transition function is a block of transaction. So in Polkadot, we call it string6. If you remember. So later in the tutorial, string6 is a like the remote code. It's not a like transaction, but it's kind of the same. Later in the tutorial, we will actually spend more time to build roper block and execute them. But for now, we can simulate what a block would do by individually calling the function of our palette expo. Genesis state. So is our Genesis state. Genesis state or Genesis block is basically the first state and the first block of the blockchain. The state of your blockchain will operate from block to block. This means if Alice receives 100 token on block 4, that she can transfer at least 100 token on block 5 and so on. For those part, mean if Alice receives 100 token on block 4, she can transfer at least on block 5 and so on. But how do user get any balance to begin with? The answer to this question could be different, but in general, most modern blockchain start reaching this state. Yeah, nothing special. So this is very interesting, and you should remember it. Yeah, I think you should remember. So whenever there are transactions sent to the blockchain network, the nonce of the sender must be increased. So in this case, we have for example, like we create a new block. So like in the practical blockchain network, there will be consensus, like block proof stack, and then it will participate in this process to like finalize the block. But right here we just purely call the method increase block number, and then like when we increase the block number, we suppose that it's already generate the new block. So when we have a new block, and then the system is gonna increase the nonce of Alice. So this block is added to the network, and then like the nonce of Alice to indicate the number of transactions, the transaction height of Alice is increased by 1. Then like the balance of Alice is also like the balance, like here is like from here to here is the first transaction, and this one is just we emulate the block in the blockchain network. But in the practical one, this one is gonna be all this one is will be in one, like in this thing called like transaction one, and then it's all the thing on the thing above, and then we send this transaction to the network. So this transaction after execution, after block finality, this transaction executed and state transition happen. State transition happen. That's how it does. Yeah. Right. That's fine. All right. So we finish simulate our first block. Let's go. This part is not. There's not too many things special. Just add the debug trait to the stroke. The debug trait in Rust is used to indicate that stroke is allowed to be debugged when the compiler run. That means that you can bring it out. So you use RS to add the debug tree for the runtime. Debug tree, and like I will add the debug tree for the palette as well. Well, we had went so far, but we still have a long way ahead. Hope that we can finish it under 2 hours. And thank you for everyone who still stay here. Like just 2 or 3 persons, I don't know, but like thank you everyone for still stay here and follow my live code. I know like it's very time consuming, and yeah, it's yeah, but hope like you're gonna learn something from it, and like just ask me any question in the chat, so I can help. Yeah, I can help like to provide any information that you need, because that's my responsibility to be here. Yeah, thank you. Now we go to another section called generic and configurable type. In this section, we will be harnessing the full power of Rust to create a generic and configurable runtime. There will be no real logical changes happening in the next step. It will be regular abstracting way. Yeah, so basically we just add generic type. So if you don't generic type Rust, yeah, you should read this documentation about generic type first in the Rust book before work on this part of the things. But basically, like this is the generic type. If you're familiar with other language, we also have that in other OOP language. It give it abstract away the type of the field. Yeah. So that's we're gonna do it for our runtime. Yeah. So basically, in the real substrate code, it has many associated type and generic type, because like we want to design a framework in a modular architecture that you just plug and play. That means like we want the palette to support multi kind of runtime as possible. So we will support we will allow the generic type. Yeah. So up to now we have just been coding more time in this stroke. I need a few minutes to read the description. We can see functions take two parameters, block number, nodes, should come type, identify custom, then okay, cool. Basically, this is what we did. This is what we did. I know I just feel so irritating in the first place. So I just have type alias. So custom type, where is it? To do. Let me copy the to do. I will remove here, make it plainer. So the to-do want us to define the common type, use palette like account ID and balance. I think we already did that. Yeah, we already did that. So ignore it. Yeah, let's ignore it. Account ID, block number, nodes. Yeah, we already did that. Import the num rate. Rest is designed to be very lightweight and provide very little right out of the box. We in the ecosystem many functional features which you expect to include the rest at the core, especially the data to small, where on value discrete. We want to access traits basic numerical operation. I see. Yeah. So this basically like this trait is widely used in numeric type of Rust like U33 or float type or integer. And then now we want to abstract away the integer that we use in our palette as well. So that's why like when you iterate into the runtime, the people can configure this dynamic type of the numeric type. So we will see it in the code. Right? So cargo add num. We add a new thread on num. We want to convert the balances palette generic. Yeah, like I mentioned, so the flexibility of generic runtimes means that we can write code which works for multiple different configuration and type. That's also the vision, like the far vision of Subtree, right? That it's become the all-in-one blockchain builder that everyone can use to build their own blockchain. So in that way, like the runtime should be generic enough to support multi-kind of configuration and type. There are definitions of the account type in both the palette balances and the system palette. Imagine if you had many more palette too, such refactoring could be very difficult, but also totally avoided if we use generic type to begin with. Truthfully, the advantage of generic type will not be super obvious in this tutorial, but when building a functionality scale and subtrate this kind of flexibility, we are not going to use storage. Okay, so here in the balance palette, we want us to update the palette struct to be generic over the account ID and balance type. We will need the type definition of both after you are done. That means we want the address and the balance to be a type instead to be like a generic type. Here, address, balance, and then address, balance. So we will provide these in the runtime code instead of we provide it directly from the palette code. So this way, it will make our runtime configurable, like I said. It also make the code cleaner. So when you want to make any changes to the trade, I mean, like when you want to make any changes to the type that you use, you just pass in from the runtime. Like the runtime will become the central place that you host your code instead of doing some very minor configuration from the palette side. So now we can remove on this type, and we go here to this palette that we have to provide when we use. So you can see like it's provide the address and also the balance. Yeah, so that's the thing, and we also want to do the same for system. What kind of things does the system ask for? Oh, they also ask for. We missed the test case. So now this become address. Balance. Insert group one. Yeah, we have to identify a few trades for this thing. I don't know like what type trade that they're gonna ask for, but I think I will do that on my own. I think it's gonna require hash to string. Yeah. Should be in the implementation instead of. And then they also ask for clone, string, balances, order, and maybe partial equal something. Does this need to string? I don't think so. And what this thing is going to be balance. So it's going to be address. This is a huge refactoring, but yeah, it's worth it. And now I think like we need check num use num. Where's my num? Call a balance. So this is gonna ask for oh, here they already give it a hint. So 0, 0. Use checkout. What? No idea why. I can use num. Oh, that's really weird. Like you cannot infer type or both. Like you see, like I cannot infer any type. I can still use it. Like the Rust compiler sometimes it's not smart like it's supposed to be. Skip this for now. So it's required partial order. I think it just depend on the way we do it. So we have to call it balance. This would be a bit messier. As order. I'll just say order. Oh, reduce. Wait, what? They have a different code compared to us, so they use checkout instead of saturating ad. So that's the reason why like they have different type. So maybe I just refactor the code a bit to match with what they expect us to do. Check soup is return check soup is return okay or right okay or flow not enough fun. I think this makes sense. This like the way they use the method is cleaner compared to what I did. So if we sub the amount and if there's an error, then this means it's not enough fun. If we don't have this thing right here, and if we add and we can see it's gonna be overflow. So need to balance okay or need to balance result okay sometimes and we don't need the order, so we no longer compare who you want. But interesting. Ooh, they're risky. How you handle that? What? Sam? Oh, we did. It may be missing some type. Oh, it's not TypeScript, sorry. What? Solution. Ah, I see. See, further time to use the method is this. Wow, that's so smart. We didn't know that we have that. Just noticed that we have the straight zero here. I need to check. If there's still someone watching, please, answer something in the comment section so like I will feel less alone. And now we have to refactor the system palette as well. Right. Back here. Yeah, like what we expecting. It's gonna be found. $74. This line. Palette. Chess and balance. Okay, cool. Now we go to the system one. What? I saw the solution already. Kidding me? Weird. System. So basically, we want every of the system to be configurable. So we got address, nonce, and block number. Look at, and then C balance. So balance will be hash one order. It's going to be 0. Check that copy. Just same thing apply for block number. Yeah. Wait, what? Check add. Receive the amount. What type should be? Add assign copy num01. Oh, it doesn't want to abstract box number. Does it? It's one. It's one. Is it one? One. And add assign. What's this add assign thing? Where's it coming from? Oh, it's configuration. And here we add assign. Oh, first time using this method. Add assign right hand side. Not any okay or things. And we do block number. We do right. One. Who will adjust to string? Mutable. So oh, and now in nonce we wait, what? In the nonce we don't say anything like add a sign. Like we should update the nonce, so it should have the add a sign, is it? Why doesn't have anything here? So add a sign. What else? So this palette is going to receive the address. It's the first attribute. Second one is the address nonce block number. Okay, cool. So expected nonce is not right. We increase the nonce of the alias. So alias non should be 1. I think because we clone the nonce, so get mutable. Oh, that's really weird. P value. What? Why did it still fail? What happened? Expected nonce. Increase. Insert news nonce. Nonce 1. All right then. Shit. But Why there's mine doesn't work? That's weird. We'll say something like can you? What? System get who knows Windows. Who? Get keys a little bit. Kidding me? So what's the problem here? So weird. My system configure. I see. Okay. So we want to clean up a bit on our code. So instead of passing the whole very long, like if we have like thousands of straight, that like we don't want to, you just add it in line like this. So we want it to have a middle config stroke config type stand between for this. So what are we gonna do? Let's just implement the balance first. So we call it straight config. In this way that we can share between our palette instead of just purely do something at this moment. Type. We infer the address from I forgot. Let me install cargo no, git clone. You will see like this will look very similar to, we basically just review the whole subtrade. We basically build the whole subtrade state machine. We clone it and we use C. So we go to the palette. No, not the palette. We go to the runtime. Go to the lib, and this is what we do. So do you remember these alias that we implement? Yeah, we implement that already, and we go to here. So here's what I'm doing is like I have just one config trait to define for all these associated type, and then all the thing is just implement a special trait that the palette is personally asking for the runtime to be define those. Like in fact, if you don't do this design pattern, you're gonna have a very long list of associated type that you need to define for every single palette, and then you cannot reuse. They just duplicate the code and make it very dirty. So we just have let's go back. Oh, we have the config. Yeah. Batches. Balance. When the runtime, we just pass in the config that we defined before. Where's our config? And we do the same things for the system. Oh, I think we must call it system config. System. Do you implement this? System config for runtime Let's defer it. We need to go here. Oh, I think we don't need the balance. Hidden block number acknowledge. How we define for the runtime? Let's go on if runtime. For the runtime. Yeah, our runtime suit type, locality, block number. When we want to migrate it to be self. Oh, that's good. So that's how it works. So system. Okay. Block number. we must have some kind of test runtime. Otherwise, how can we test this? You know, let me see. Yeah, they have some kind of test config. Test config. Just all right. We already finished. Make the system configurable, and I think like we're quite close. Like we're very close to the end of this things. Like we already make system configurable, make balance configurable, and I even implement the tie coupling already. So for tie coupling, like you see the balance, we're gonna implement. If you see the solution, the balance, we're gonna implement the system config, which I already support that. So yeah, so we finished like the first 4 chapter of this tutorial, and I must say that this tutorial is so good. It's very very good, and like sounds Tabrizi, like the guy from Parity, the core developer Parity, he's made this, and I think like everyone who wants to learn about Subtree, they should follow this tutorial. I just know about it, but I haven't finished and the tutorial before, and I just have a chance to finish it, work on it today with you guys. I just finished the first 4 chapter, and yeah, yeah, that's really good. Um, yeah, I think like yeah, it's a bit too late. It's a bit late, and it's already like 2 hours and 30 minutes, and I'm a bit hungry. I haven't had dinner yet, so thank you guys for follow this live stream, and for the rest of like from chapter 5 to chapter 6 and chapter 7, I will cover it in maybe like tomorrow live stream, or if I don't have time to in tomorrow, I will definitely make a YouTube video for it, so that you can rewatch it on the YouTube for the the full flow of the tutorial. Uh, so yeah, thank you everyone for follow the live stream, and I know like there's many part which are is a bit time consuming because I don't remember the syntax, or I'm have I don't remember like the right method to use. So but yeah, anyway, let's still thank you everyone for having me, for coming to the live stream and watch it to the end.